Hello guys and gals, and welcome to our next video focusing on the practice problems of our Unit 5 Part 2 notes. So in this video we're going to start with practice problem number 3. And practice problem number 3 says nitrogen monoxide gas and oxygen gas react to form nitrogen dioxide gas. And it gives us the rate law. And in the rate law we can see that nitrogen monoxide is second order and oxygen gas is first order. So if the reaction occurs in a single elementary step, that is a three-body molecular collision, then which of the following is an equation for the elementary step? Well, they're giving you a couple of hints here. First of all, they've already given you the rate law, and they told you it was an elementary reaction. Because of that, we know that the orders in this rate law are the coefficients of the balanced chemical equation. Okay, now they did not give us an order for the product. Of course, we don't include the product in rate law, so we will need to make sure that whenever we find an answer choice that the reactants and the products are balanced. Okay, but they also told you that it's a three molecular body collision, meaning that a very rare thing is about to occur in the fact that three particles are about to collide at the same time. So let's take a look at this. A says N plus O plus O. Well, here's a problem, because N and O, just O, not O2, but just O, are not the reactants. So A cannot be correct because the reactants are compounds. They are not individual atoms or elements, so A is off the wall immediately. Now B says 2NO plus O2 produces 2NO2. Now that does line up with the orders that we see in the rate law. So it makes B a pretty good contender. And everything is balanced in it, which makes B an even better contender. But let's double check and make sure that C and D don't have anything better. C, again, does not contain nitrogen monoxide, so therefore it cannot be the correct balanced equation. And D, again, does not contain nitrogen monoxide, so it cannot be the correct answer. So B is our correct answer. Pay close attention to the fact that it is an elementary reaction, meaning that the coefficients are the orders of each reactant. All right, now let's move on to see if we can start talking about practice problem 4. Takes a minute to get there. Okay, here we go. So, the particle models shown above represent a proposed two-step mechanism for the destruction of ozone in the upper atmosphere. Based on the proposed mechanism, what is the balanced chemical equation for the overall reaction? So what they're doing here is they're giving you the mechanism that the reaction is occurring through, meaning that they are showing you the elementary steps that form a complex reaction, and they're asking you what the equation for that complex reaction is. So let's look at it. If the dark circles are oxygens, I see O3. When they're close together and they're touching like that, that means that they are bonded. So I see O3 reacting with one chlorine. In that reaction, it produces O2 and chlorine oxide. Okay, but that is not the overall reaction. That's just one step to the reaction. So let's look at step 2. I see a chlorine oxide reacting with another O3 particle to produce two oxygen, O2 molecules and chlorine. So the fact that chlorine alone, not bonded to anything, is in the first step as a reactant and in the final step as a product tells us that this is going to be a catalyst. And we tend not to include catalysts in our final balanced equation. Now, sometimes we might include them over the yield sign to tell people, hey, this is the catalyst that we were using in this reaction. But we usually will not see it as a reactant and a product, because remember, catalysts are not used up. It starts one way, it ends in that exact same way. So we're actually not going to use chlorine as a reactant here, even though I know that it's in this first box, but we're not going to use it. Also, I see that in step 1 we form a chlorine oxide molecule, and then in step 2 that chlorine oxide molecule is used up, meaning that that chlorine oxide molecule is an intermediate, another piece that is not put in the overall equation because it's technically not a reactant. It is formed by the reaction and then it is simultaneously used up by the reaction. So we are not going to include chlorine and we are not going to include chlorine oxide in our answer. Well, that immediately takes out every single answer choice except for D. But let's make sure that our particle representation is balanced as this equation shows that it should be. So at the beginning of step 1, we have an O3. We have another O3 molecule show up at the beginning of step 2. So that means that we did start with 2 moles of O3. At the end of step 1, we produce 1 molecule of O2. And then at the end of step 2, we produce 2 more molecules of O2. And we don't consume O2 at any point in this reaction, so we do in fact produce 3 moles of oxygen gas. So that is it for practice problem 4. The correct answer is D. We do not include the catalyst chlorine, and we do not include the intermediate chlorine oxide. Okay? All right, I think that's as far as I'm going to take it in this video because next we'll be getting on into another section. So let me know if you have any questions.